Hello, and welcome to the Science for Sleep channel. Tonight, we'll explore the solar system, a cosmic family of worlds orbiting a magnificent sun for 4.6 billion years. From Mercury's scorching surface to Neptune's frozen winds, from Jupiter's great red storm to Saturn's ethereal rings, our solar system is a symphony of motion and gravity. Drift into peaceful slumber while discovering the endless dance of 8 planets, mysterious moons, and the silent vastness between worlds. Let your mind relax, your breathing slow, and your body grow light. If this helps you rest, please like and subscribe. Now let's begin, one sleepy soul at a time. The Sun contains 99.86% of all the mass in the solar system, a concentration so profound that it dominates gravitationally every world that orbits around it. This colossal star, a ball of fire powered by nuclear reactions, maintains in orbit 8 planets, countless moons, asteroids, and comets through its enormous invisible force. Every atom of the worlds that orbit depends upon this fundamental gravity. The majority of celestial objects around us circle this single star that is the engine of all life here on Earth. Venus rotates backwards, different from all other planets in their movement around the Sun. This mysterious planet spins in the opposite direction to most of its cosmic neighbors, an extraordinary legacy of its turbulent history billions of years ago. Scientists believe a giant collision reversed its rotation during the early times of the solar system. This retrograde movement makes it unique among the 8 worlds that dance around our star. A day on Venus is longer than its year, a fascinating inversion that defies our common understanding of time. The extremely slow rotation of Venus means that the planet takes approximately 243 Earth days to spin once on its axis. However, its orbit around the Sun requires only 225 Earth days, a beautiful and contemplative contradiction of cosmic nature. Thus, on Venus, circular time moves differently from all that we know. Jupiter is so large that it could contain 1/300 Earths within its boundaries, a gaseous giant of incomprehensible proportions. This cosmic colossus possesses a mass that exceeds all other planets of the solar system combined together. Its vastness humbles us, showing how small our blue world is compared to the true titans of the cosmos. To observe Jupiter in the night sky is to contemplate the pure grandeur of celestial creation. The great red spot of Jupiter is a giant storm that has lasted for centuries, possibly since 1831, when it was first observed. A huge vortex of gases rotates continuously, larger than planet Earth itself, a cosmic hurricane that never ceases. Scientists observe this phenomenon gradually diminish over the years, yet it remains a tempestuous marvel that reminds us of the dynamism of outer worlds. This storm is 2,000 times wider than Earth's hurricanes. Saturn has 145 confirmed moons, an ancient planet surrounded by a true family of natural satellites dancing around it. Each moon orbits in its specific path, each one with its own cosmic history and unique composition, forged in the dawn of the solar system. Some of these moons are gigantic as worlds, while others are small fragments of icy rock. This complex lunar system creates a gravitational harmony that endures for billions of years. The rings of Saturn are composed primarily of ice, billions of particles of frozen water, and rock that dance together in perfect gravitational harmony. These particles reflect sunlight in sublime ways, creating the most beautiful visual spectacle of the solar system. The rings are not solid, but rather countless small objects in synchronized orbit, each one following its predetermined path for eons. The delicacy of these rings contrasts with the colossal magnitude of the planet that surrounds them. Uranus was the first planet discovered in modern times during the year 1781, when astronomers detected a new light in the night sky. Telescopes revealed a new world, instantly doubling the known size of the solar system with this extraordinary discovery. This event marked a turning point in astronomy, showing that we had understood so little about unknown worlds still waiting to be discovered. The discovery of Uranus humbled us once again, revealing our cosmic ignorance. Uranus rotates almost perpendicular to its orbital plane, tilted at an extreme angle that makes it unique among all planets. This icy planet is practically lying on its side as it orbits the Sun, possibly due to a giant cosmic collision in its distant infancy. This dramatic inclination creates extraordinary seasonal cycles, where each pole will experience decades of total darkness, followed by decades of continuous light. The strangeness of this world reminds us that the universe is full of surprises. Neptune has the fastest winds ever recorded in the solar system. Hurricanes with speeds up to 2,100 kilometers per hour sweeping through its deep blue atmosphere. This distant planet, invisible to the naked eye from Earth, is a world of extreme atmospheric dynamics despite being so far from the Sun. Scientists observe these dark storms dance in the metallic blue of the planet, creating patterns of beauty and chaos simultaneously. These winds are almost 20 times faster than the strongest hurricanes on Earth. The Oort cloud envelops the entire solar system in a theoretical invisible sphere that extends to incomprehensible distances from our Sun. This cosmic shield contains billions of icy bodies that surround our system of worlds, protecting it from incursions of interstellar space, a layer so vast that it would take light thousands of years merely to traverse its outer periphery. This mystical region marks the true boundary between our cosmic home and the abysses of the universe beyond. The Kuiper Belt contains millions of icy objects that orbit silently in the coldest and most distant regions of the solar system, beyond the direct reach of the Sun's warmth. This distant zone is filled with small worlds of ice and rock, remnants from the time when the solar system was forming billions of years ago. Here, in the cold silence, rests an entire population of frozen asteroids that have never been touched by recent history. These trans-Neptunian objects testify to the primordial youth of cosmic creation. Pluto was considered a planet for 76 years until the scientific community reclassified it as a dwarf planet in 2006 after extraordinary new discoveries emerged. This distant world, discovered in 1930 with great fanfare, was downgraded when other similar worlds were found in the same region of space. The reclassification of Pluto shows how our cosmic knowledge continues to evolve and refine with each observation and discovery. Even in its new status, Pluto remains a world worthy of contemplation and study. The asteroids between Mars and Jupiter never formed into one complete planet, leaving only fragments and debris from an incomplete formation long ago. This fragmented region, called the asteroid belt, guards the primitive remnants of the solar system's birth 4.6 billion years in the past. Small collisions occurred billions of years ago, preventing these fragments from condensing into a single, cohesive world. The asteroids testify to a history of cosmic violence and uncertain destiny in the system's youth. The solar system moves through the galaxy in an eternal and cyclical journey, traveling at approximately 230 kilometers per second continuously. Our entire family of worlds, the Sun and all its orbits, traverse a galactic path that takes 225 million years to complete one full revolution. At this very moment, we are traveling through regions of space that our ancestors never knew existed. Billions of years from now, we will be in different locations within the vastness of the Milky Way. Mercury is the fastest planet in the solar system in its orbit, dancing closer to the star than any other cosmic neighbor. This small rocky world completes one lap around the Sun in merely 88 Earth days, racing through the skies incomparably faster than its more distant siblings. Mercury's proximity to the Sun forces it into a feverish and accelerated existence compared to the slow rest of outer worlds. Its name appropriately derives from the messenger of the gods, forever hurried in its cosmic duties. Mercury experiences the greatest temperature variation among all planets of the solar system, suffering extremes that defy the imagination. During the day, its barren surface reaches 430 degrees Celsius under intense solar heat, while during night it plummets to 180 degrees Celsius below zero. This brutal thermal amplitude of 610 degrees reflects the lack of protective atmosphere and proximity to the Sun. No other world experiences such radical fluctuations between light and darkness. Venus is the hottest planet despite not being closest to the Sun, a paradox that teaches us about the power of an uncontrolled greenhouse effect in space. An extraordinarily dense atmosphere of carbon dioxide envelops this tormented world, trapping solar heat and creating an inferno of 460 degrees Celsius at its surface. The clouds reflect sunlight away, yet the greenhouse effect amplifies the heat retained beneath the oppressive atmospheric layer. Venus is a warning about what can happen when a greenhouse effect spirals beyond control. Mars possesses two natural satellites named after deities from Greek and Roman mythological traditions of war and conflict. Phobos and Deimos circle Mars like tattered guardians of an ancient planet that witnessed billions of years of solitary cosmic evolution. Phobos is the larger of the two, an irregular rocky mass that gradually approaches Mars over eons. Deimos, the more distant, orbits in relative peace, a silent companion in this Martian dance. Mars hosts the largest known volcano in the entire solar system, a colossal structure called Olympus Mons that defies all comprehension of planetary scale. The base of this volcano would cover territory larger than all of France, a shield volcano of astronomical dimensions that rises gently above the Martian surface. Despite its impressive height being less than expected compared to its gigantic base, Olympus Mons remains a monument of geological power. This silent volcano witnesses eons of volcanic activity on a world long since gone cold. Earth sits in the middle of the habitable zone of the solar system, a special location where the Sun's heat is neither excessive nor insufficient for life to flourish. Our blue planet occupies a privileged space in the orbital dance, not too close to be scorched, not too distant to be frozen in eternity. This precise positioning has allowed water to remain liquid for billions of years, creating the perfect cradle for the emergence of life as we know it. Earth is an oasis among barren and frozen worlds, a unique jewel in all the cosmic vastness. Moons influence their planets through gravity in ways we do not fully comprehend, slowly sculpting the worlds that orbit them across billions of years. Natural satellites do not merely circle their parent planets, but gradually alter their axial tilts and modify their rotational speeds through continuous gravitational interactions. Our moon, for example, reduces the speed of Earth's rotation in measurable ways across geological time. This gravitational dance between world and moon testifies to the invisible power that governs all cosmic structure. The solar system is dynamically unstable on very long time scales, revealing that current harmony is merely temporary from a cosmic perspective. Small gravitational perturbations and imperceptible orbital changes might, millions or billions of years in the future, completely reorganize the orbits of all 8 planets around our Sun. Computer models suggest this ordered system could eventually become chaotic on extremely long timescales. The stability we observe now is an illusion created by our limited human perspective. Comets are ancient travelers from space that originate from the most remote and primordial regions of the solar system, carrying ice-old messages from a time long before Earth's birth. These nuclei of ice and dust were formed 4.6 billion years ago and spend most of their time dormant in distant regions. Occasionally, a gravitational perturbation awakens these ancestral bodies and sends them on trajectories that carry them toward the inner solar system. When they approach the Sun, their ice vaporizes and creates the luminous tails that have fascinated us since ancient times. The Sun has consumed half its hydrogen fuel supply, the nuclear fuel that sustains its existence, marking that we stand at the midpoint of stellar life. The star that illuminates us has burned for 4.6 billion years at this delicate balance, fusing hydrogen in its core through continuous nuclear reaction. Within several billion more years, the Sun will complete its transformation and expand enormously, marking the end of the current era. For now, we benefit from the steady light of a middle-aged star in its contemplative splendor. The planets do not orbit in a perfectly flat and level plane, but rather in orbits that have subtle inclinations that shift them slightly away from the ecliptic plane. Each world tilts at a slightly different angle relative to the common plane, defined by Earth's orbit. These minimal variations create a delicate three-dimensional ripple in the solar system's orbital structure that astronomers call orbital inclination. Even in these minuscule differences, we see the fine-tuned complexity of celestial mechanics. The average distance between Earth and the Sun defines the astronomical unit, a fundamental measurement that serves as the standard scale for measuring distances within the entire solar system. This measure of approximately 150 million kilometers establishes the standard by which we describe the orbits of all other planets and celestial bodies. When astronomers discuss distances within the solar system, they frequently use this unit rather than kilometers to simplify incomprehensibly large numbers. 1 astronomical unit is a measure of convenience that makes the immense comprehensible. Jupiter completes one orbit around the Sun every 12 Earth years, moving much more slowly through the heavens than its smaller neighbors closer to the Sun. This gaseous giant remains in each zodiacal constellation for roughly 1 year while moving its orbital position, creating a slow and majestic rhythm in its journey. In comparison with Mercury, which darts about quickly, Jupiter moves like an ancient monarch, advancing with grace and patience through its predetermined orbital trajectory. Jupiter's slowness reflects its distance and its freedom from the urgency of solar proximity. Saturn takes 30 Earth years to orbit completely around the Sun, an adorned giant that advances majestically through the zodiacal constellations in a slow and contemplative dance. This planet weighs so much and orbits so far from the Sun that its complete revolution takes 3 decades of Earth time. A person living a normal lifespan would observe Saturn move only 1 or 2 positions in the zodiac during their existence. This extreme slowness confers upon Saturn an almost timeless and patient quality in its cosmic journey. Uranus requires 84 Earth years to complete one orbit around the Sun, meaning it spends approximately 7 years in each zodiacal constellation. A typical human lifetime permits a person to observe Uranus traverse only a small fraction of its complete orbit. This icy and distant world moves so slowly that its orbital progression is nearly imperceptible on human timescales. The distance of Uranus from the Sun places it in a dilated and slow time where millennia pass in silent contemplation. Neptune takes 165 Earth years to orbit completely around the Sun, a distant world that moves so slowly that it has completed barely one full orbit since its discovery in 1846. This giant of ice and profound blue occupies a place so remote that its orbital trajectory is almost imperceptible on human timescales. A child, born when Neptune was discovered, would never live to witness the planet complete a single full circle around the Sun. This extreme slowness confers upon Neptune an almost eternal quality in its orbital pattern. The space between the planets is predominantly empty, despite incomprehensible trillions of kilometers of separation between each world orbiting our Sun. The vastness between Mercury and Earth is filled primarily by solar radiation and the invisible solar wind that constantly flows from the Sun. Even Jupiter, the giant of all worlds, appears as a tiny sphere compared to the immensity that surrounds it. In this nearly infinite vastness, the worlds orbit in relative gravitational isolation from one another. The solar wind is a continuous and invisible stream of charged particles that the star constantly expels in all directions, permeating the entire solar system with its presence. Billions upon billions of atoms leave the solar corona every second, traveling through the vacuum and carrying with them the Sun's magnetic influence. This wind is not violent like an earth storm, but rather a constant breeze that fills the cosmos with matter and energy. Even here on Earth, we feel indirectly the effects of this solar wind when auroras illuminate the polar skies. Earth's magnetosphere protects us from the solar wind in ways that escape our complete comprehension, an invisible shield that envelops our planet like an eternal guardian. An invisible magnetic field generated by our planet's liquid iron core deflects charged particles from the solar wind toward the polar regions. Without this protective magnetic field, solar radiation would strip away our atmosphere and destroy all complex life on the surface. The magnetosphere is a cosmic gift that makes life as we know it possible. Auroras are the visible result of solar wind particles colliding with our atmosphere in polar regions, creating dancing lights that have enchanted humanity since ancient times. When charged atoms from the solar wind collide with oxygen and nitrogen molecules at our upper altitudes, they release energy as green, red, or violet light. The aurora borealis and australis represent this cosmic dance between the Sun and Earth, visible only when conditions align favorably. These phenomena connect us viscerally to the cosmic processes governing our existence. Planetary rings are in constant change and evolution, not static structures, but rather dynamic systems of ice and rock in perpetual rearrangement. The ice and rock of Saturn's rings migrate gradually through space, with smaller satellites altering their orbits slowly through imperceptible gravitational interactions. Occasionally, new rings form, while others disappear in the geological history of gaseous giants. The rings we observe today are merely one fleeting moment in an evolution spanning billions of years. Titan, Saturn's moon, possesses a dense and complex atmosphere that makes it unique among all natural satellites of the solar system. This enigmatic moon has a gaseous covering denser than Earth's, composed primarily of nitrogen with traces of methane. Beneath its opaque haze, scientists believe oceans of liquid exist and landscapes shaped by processes similar to those on Earth. Titan is a world so complex it deserves consideration as a planet were it not for its orbit around Saturn. Europa, Jupiter's moon, hides an ocean of liquid water beneath a layer of ice that may contain primitive, microscopic life in its depths. This icy satellite generates heat through tidal forces caused by orbiting Jupiter, maintaining water in liquid state even in the distant cold of space. Scientists speculate that Europa may be one of the most promising locations to discover extraterrestrial life in the solar system. The hidden ocean of this small moon represents a final frontier for future cosmic exploration. Io, Jupiter's moon, is the most volcanically active body in the entire solar system, with hundreds of erupting volcanoes continuously transforming its surface. Io's volcanic activity is driven by internal friction caused by Jupiter's gravitational forces, creating a lava hell that never ceases. Volcanoes on Io expel lava and sulfur at extreme temperatures, resulting in a landscape that changes constantly. This infernal world reminds us that geological activity can reach levels that defy our terrestrial experience. Mars experiences seasonal patterns remarkably similar to Earth because its axial inclination is comparable to ours, creating seasonal variations that affect its atmospheric and climatic dynamics. Although Mars is much colder and more arid than Earth, its poles experience cycles of freezing and thawing, while the equatorial region experiences temperature variations throughout the Martian year. Mars's seasons differ slightly from Earth's because its year is longer and its orbit more eccentric. These seasonal cycles suggest Mars experienced complex climatic processes billions of years in the distant past. Mercury possesses no significant atmosphere, leaving the small planet near the Sun exposed directly to the vacuum of space and intense solar heat without protection. This desolate world experiences direct solar radiation and extreme temperature fluctuations that are virtually unbearable for any form of life we know. The absence of an atmospheric layer means Mercury cannot retain heat, creating the most extreme temperature variations of all rocky worlds in the solar system. Mercury is a naked, exposed, and pure world in its cosmic hostility. Venus possesses an extraordinarily dense atmosphere 90 times heavier than Earth's atmospheric blanket, a crushing atmospheric pressure that would be fatally compressive for any creature evolved on Earth. This dense atmosphere consists primarily of carbon dioxide with clouds of sulfuric acid, creating a chemical inferno that no human could endure for more than seconds. The pressure at Venus's surface is equivalent to the pressure found kilometers deep in Earth's ocean depths. Venus represents an apocalyptic scenario of a world suffocated by dense gases and heat beyond measure. The system of rings is not exclusive to Saturn, despite its rings being the most impressive and easily observed through simple telescopes. Jupiter, Uranus, and Neptune also possess rings that orbit their equators, though far more fragile and difficult to detect than Saturn's magnificent bands. Jupiter's rings are thin and dark, composed primarily of fine dust and small rocky fragments. Uranus and Neptune's rings are even more tenuous and practically invisible from Earth, revealing a diversity and complexity in ring structure that surprised astronomers. Mars's axial inclination is remarkably similar to Earth's, with both planets having axes tilted approximately 25 degrees relative to their orbital planes. This similarity creates comparable climatic dynamics between the two worlds, despite obvious differences in their surface characteristics and atmospheric compositions. Both planets experience changing seasons that affect their climatic patterns throughout their respective years. This similarity between Mars and Earth reminds us that fundamental patterns in orbital mechanics repeat themselves across different cosmic scales. Ganymede, the largest moon of Jupiter, is the largest natural satellite in the entire solar system, a structure so immense it exceeds planet Mercury in size, despite being merely a moon. This icy world orbits Jupiter in a gravitational dance that has endured billions of years, maintaining a stable orbit within this complex Jovian system. Ganymede is so large, its own gravity forces it into a spherical shape, not as an irregular rocky fragment. Ganymede's magnitude shows that moons can be worlds in their own right. Phobos, the larger moon of Mars, is gradually approaching the planet in an orbit that constantly draws it nearer to the surface. This chaotic and irregular satellite will eventually collide with Mars or be shattered by gravitational forces within tens of millions of years ahead. Phobos's approach toward Mars is predictable and inevitable, a destiny written by gravity that will continue its course inexorably. This process represents the long-term dynamics of planetary satellite systems. Deimos, the smaller and more distant moon of Mars, moves slowly away from the planet in a trend opposite to its brother Phobos. This outer satellite continues its gradual journey away, carried by orbital dynamics that propel it centimeter by centimeter over millions of years. While Phobos is destined to collide with Mars, Deimos will eventually escape and become an independent object wandering through space. The two Martian moons represent opposite destinies in the orbital dance. The planets formed from a primordial disk of dust and gas surrounding the newborn sun through a gradual process of condensation and collision. The primitive solar nebula gradually condensed material through constant collisions and mass collection, forming the embryos of worlds that currently orbit our sun. Small dust grains collided and merged into larger bodies, which in turn collided with others to form the planetary embryos. This process of agglomeration represented the slow birth of each world through catastrophic impacts. The first planets to form were the gaseous giants Jupiter and Saturn, which condensed rapidly before the primitive solar disk completely dissipated. These colossal worlds grew so quickly they captured much of the primordial hydrogen and helium available in the disk. The smaller planets, including terrestrial ones like Earth, took much longer to form from remaining material. The rapid formation of the gas giants determined the fundamental structure of the solar system as we know it. The late heavy bombardment was a catastrophic event that completely reshaped the primitive solar system approximately 4 billion years ago through a series of violent collisions. Gravitational perturbations caused by the unstable orbits of gas giants resulted in massive planetary migration and catastrophic collisions between primitive worlds. This period of cosmic violence was responsible for impact craters observed on the Moon and other ancient worlds. The late heavy bombardment left scars that persist as silent witnesses to the turbulence of the young solar system. All planets are held in their orbits by the Sun's invisible gravity, a force that silently governs the heavens without rest across billions of years. This fundamental force, which no eye can see but all can feel, has guided the worlds in the same predictable dance for eons without interruption. Each planet follows its orbital path, attracted by the Sun's gigantic mass that keeps them trapped in an eternal gravitational embrace. Gravity is the invisible chain that binds each world to its cosmic destiny and to its parent star. The inner planets are small and rocky, composed primarily of hard stone and metals that solidified billions of years ago through cooling and compression. Mercury, Venus, Earth, and Mars share a solid and compact nature that reflects their formation near intense heat of the young sun. These worlds were forged in the heat of the primitive solar system, where only the most refractory materials could condense and remain solid. Rocky planets show us the diversity that can exist even when composed of the same fundamental type of matter and elements. The outer planets are immense and gaseous, giants that flow without solid form or clear definition in their ethereal and dynamic structures. Jupiter and Saturn formed in the coldest and most distant regions of the primordial disk, where hydrogen and helium could be captured before dispersal by the solar wind. These colossal spheres of gas represent a different class of world, one that will never know solid ground beneath its being. Gas giants remind us that the variety of possible worlds is far greater than our terrestrial home. Each planet follows its own unique and individual orbit through the vacuum of space, a path that belongs to it alone throughout time. Although all orbiting the same central sun, each world travels in a slightly different trajectory, defined by its mass and orbital position at the solar system's birth. No two worlds follow exactly the same path, creating a diversity of cosmic highways. The unique orbits of each planet constitute the fundamental structure of solar system harmony. The planetary orbits are slightly elliptical and not circular, creating a complex dance of varying proximities to the Sun throughout orbital periods. No planet follows a perfect geometric circle, but rather an elongated ellipse, with the Sun occupying one of its two focal points. This orbital eccentricity means each planet is sometimes closer and sometimes farther from the Sun in its annual journey. Elliptical orbits create rhythmic variations in the solar energy each world receives. Planets align in rare and beautiful configurations that occur periodically when two or more worlds appear close to each other in the night sky. These celestial conjunctions offer rare opportunities for Earth observers to contemplate multiple worlds in apparent proximity, a sight that doesn't repeat regularly. Ancient astronomers observed these special alignments and created stories about their cosmic significance. Today, these alignments continue to inspire wonder and fascination in anyone watching the night sky. Asteroids occasionally impact planets, bringing scars of collisions that register histories of catastrophic encounters written in rock and frozen dust. These rocky bodies, wandering through space, occasionally intersect planetary orbits, resulting in impacts that leave permanent craters as witnesses to cataclysmic meetings. Asteroids represent a constant danger, but also an opportunity to study the history of the primitive solar system. Each impact crater preserves information about events that shaped the worlds orbiting our Sun. The solar system has an age of 4.6 billion years, a time that has elapsed since the molecular nebula's collapse that created the Sun and its associated planets. This period represented an extraordinary journey of cosmic evolution, during which worlds formed collided and evolved across the vastness of space. Billions of years have passed since then, and billions more will come before this era ends. The solar system's age places us in cosmic perspective of an antiquity almost beyond human comprehension. The sun continues slowly to consume its hydrogen fuel through continuous nuclear fusion occurring in its mysterious core. The fusion reaction transforms hydrogen into helium, releasing colossal amounts of energy in the process that warms and illuminates us here on distant Earth. This process proceeds inexorably, transforming matter into energy and light through fundamental laws of nuclear physics. The sun's nuclear combustion is the primary source of all energy that drives life and dynamics within the solar system. Natural satellites orbit their planets in ordered ways, each moon following its path around its parent world in a stable gravitational system. Small moons orbit close to their planets, while larger moons orbit more distantly, creating gravitational harmony that has persisted across billions of years. Each moon represents a silent companion to its planet, a constant presence that influences tides, seasons, and atmospheric dynamics. Natural satellites show the profound interconnection of all cosmic objects through the force of gravity. The day-night cycle varies dramatically between planets in the solar system, with some worlds experiencing days lasting months, while others complete rotations in merely hours. Venus takes 243 days to spin once on its axis, creating days far longer than its orbital year. Jupiter, by contrast, completes one rotation in merely 10 hours, creating day-night cycles repeating several times during a single Earth day. This extreme variation shows how fundamentally different worlds can experience the passage of time. Surface gravity varies dramatically among planetary worlds, where an object placed on Jupiter's surface would weigh far more than on Earth, while on the Moon it would weigh substantially less. Each planet possesses its own gravitational strength determined by its mass and size, creating a unique experience for any object resting on its surface. A human weighing 100 kilograms on Earth would weigh 300 on Jupiter's surface, but only 16 on the Moon. Variable gravity demonstrates how each world offers a completely different environment. Planets possess different chemical compositions, reflecting the materials available and conditions prevailing when each formed in different regions of the primordial disk. Some worlds are rich in iron and silicon, forming dense rocks, while others are primarily hydrogen and helium, creating giant, endless atmospheres. What is solid rock on one planet may be gas or liquid on another, depending on the unique temperature and pressure of that world. The varied composition of planets shows the chemical diversity the solar system accommodates. Planetary temperatures decrease gradually with distance from the sun, creating thermal gradients determining what environment each world experiences. Mercury, close to the sun, suffers temperatures hot enough to melt lead, while Neptune, distant and remote, remains frozen in near absolute cold at 230 degrees below 0 Celsius. Each planet occupies its own thermal zone, determined precisely by its orbital position in this celestial dance. Temperature is a fundamental factor molding all planetary characteristics. Natural satellites stabilize their planets through mutual gravity, a delicate relationship affecting axial tilts and orbits across billions of years. The Moon, for example, reduces Earth's rotational speed in measurable ways across geological timescales. Without stabilizing satellites, many worlds would experience extreme climatic fluctuations caused by changes in axial inclination. Satellites are more than silent companions. They are guardians preserving world stability. Each planet has its own unique atmospheric dynamics, with wind currents, pressure patterns, and chemical composition creating an individual signature. Jupiter possesses equatorial zones and high-latitude bands creating complex atmospheric circulation patterns, while Venus maintains a dense, super-rotating atmosphere circulating the planet in merely 4 days. Each planetary atmosphere tells a story of dynamic processes occurring continuously in upper layers. Atmospheres transform sterile worlds into complex systems of circulation and weather. Comets visit the inner solar system occasionally, ancient travelers from most distant primordial regions, bringing old ice from primordial times. When gravitational disturbance releases a comet from the Oort cloud, it begins a journey potentially taking decades or centuries reaching the inner system. As they approach the Sun, their ice vaporizes, creating the luminous tails inspiring awe and contemplation. Comets are ambassadors from ancient times, carrying messages from distant epochs. Planetary orbits remain stable across medium timescales, showing billions of years of ordered movement, demonstrating the fundamental harmony of cosmic architecture. No planet deviated significantly from its orbit during the billions of years since solar system formation, allowing Earth life to evolve in relative stability. This stability is remarkable given the complexity of gravitational interactions among multiple massive bodies. The solar system shows that order and predictability can endure eons when initial conditions align favorably. The solar system continues slowly to evolve, with subtle gravitational perturbations altering each orbit gradually, imperceptible on human timescales. Small changes accumulate across millions of years, creating orbital migrations, reshaping the system's entire structure. Astronomers observe Mercury slowly approaching the Sun, while other worlds experience similar orbital alterations. The solar system's continued evolution shows that nothing is truly immobile or eternal in the cosmos. All worlds inherit elements created in prior stellar generations, exploding in supernovae before our Sun's birth. The carbon, oxygen, iron, and silicon composing the planets were forged in stellar furnaces and dispersed through space by cataclysmic explosions. The matter forming each planet traveled through the universe billions of years, passing through countless stars before condensing here. Every atom in our worlds is a relic from a cosmic past preceding solar system formation. Planets are born from gravitational collapse of primordial material, a process where a local concentration of gas and dust in spiral formation gradually transforms into solid worlds over vast periods. Gravity pulls incessantly, drawing particles ever closer until pressure and temperature force nuclear reactions. This slow and inexorable process formed each planet orbiting our Sun, built layer upon layer through collisions and continuous compression. Planets are products of cosmic patience and unrelenting gravitational force. The gas giants exercise strong gravitational influence on their neighbors through their enormous mass, guiding and shaping asteroid and comet orbits invisibly from across immense distances. Jupiter particularly acts as a cosmic guardian, its gravitational field capturing or expelling objects approaching too closely. This influence extends to vast distances, altering orbital trajectories and preventing certain objects from reaching the inner solar system. The gas giants are invisible architects of the orbital structure we observe and study. Rocky planets preserve scars of ancient collisions on their surfaces, marked by impact craters telling stories of cataclysmic encounters in the distant past. These scars are permanent records of an epoch when the solar system was far more chaotic and violent than today. The Moon brims with ancient craters, while Mercury and Mars similarly show evidence of intense bombardment eons ago. Each crater monument silently honors a collision that shaped cosmic history. Moons formed through diverse and varied processes, some satellites condensing alongside their planets, while others were captured by external gravity after wandering through space. Earth's moon is believed to have formed from a piece of our planet that separated during a gigantic collision. Other satellites were captured by gas giants and trapped in orbit through gravitational maneuvers. The varied origin of moons shows the creativity and complexity of cosmic processes. The solar system functions as a perfect cosmic clock, its predictable and ordered movements serving as a reliable metrometer of the universe. Since ancient times, astronomers used planetary movements to measure time and predict future cosmic events with remarkable precision. This system's regularity permits us to understand fundamental laws of physics governing the cosmos. The solar system teaches that order and predictability emerge from simple mathematical rules. Worlds continue orbiting the sun in infinitely repeating patterns, day after day, night after night, the celestial dance proceeding along its eternal trajectory endlessly. Each planet follows its predetermined path, neither accelerating nor decelerating, trapped in motion, lasting billions more years. This constancy offers comfort, a sense of order and stability in a universe often seeming chaotic. Orbiting worlds are the constant upon which we can always rely. Planets move slowly through the night sky as observed from Earth, requiring patience to detect motion as they take weeks to shift noticeably. Venus, brightest of planets, gradually moves from one side of the sun to the other, while Mars follows more complex patterns including retrograde motion. Observing planets across this in years offers profound perspective on orbital dynamics. Slow planetary motion rewards patience with cosmic understanding. Space exists between all celestial bodies in near complete emptiness. This vast and silent void, separating each world from the other, filled only by invisible radiation and gravity knowing no distance. Despite trillions of kilometers of separation, worlds remain connected by gravity, an invisible cord uniting them. The void between worlds is where most universe history occurs, an empty stage awaiting cosmic actors. This emptiness reminds us of immensity and cosmos loneliness. Natural satellites orbit their planets slowly, in predictable patterns, night after night. The same moons reappear circling their worlds in movements continuing eternally. The moon circles Earth every 28 days, a rhythm shaping human calendars for millennia. Larger moons orbit more slowly, while smaller moons orbit more rapidly, each following laws imposed by celestial mechanics. Satellites are loyal companions, never abandoning their worlds. Planets continue their journey through space alongside the sun, a family united in silent motion through the galaxy, all moving together in a voyage lasting billions of years more. No planet could escape the sun's gravitational embrace. The distance between them so vast, the sun remains dominant always. The entire family of worlds travels in unity, inseparable by the invisible force uniting them. The solar system is a coherent unit, traveling through the universe as one organism. Worlds are bound to their orbits by the sun's gravity eternally, never deviating, continuing their celestial paths without end. The gravitational force holds each planet in its place, maintaining the orbital dance that began billions of years ago. Time passes, seasons change on worlds, yet the orbits remain constant and unbroken. The worlds turn slowly through endless space, bound together by invisible forces that never weaken or falter. Planets move around the sun in their slow and patient journeys through the cosmos, each following paths established long ago. Mercury races quickly while distant Neptune moves with extreme slowness, yet all follow paths predetermined since birth. The rhythm of orbital motion continues without interruption. Day after day, year after year, millennium after millennium. The movements of worlds are the heartbeat of the solar system itself. Stars drift slowly above us as Earth turns beneath our feet, though what we perceive as motion in the sky is actually our own planet moving. The stars remain fixed while we orbit, yet from Earth's perspective, the planets appear to wander. This cosmic perspective shift reveals that all motion is relative to the observer. Understanding this transforms how we comprehend our place in the celestial dance. Gravity continues to hold worlds in eternal suspension, neither pulling them closer nor allowing them to escape into endless void. The balance between orbital velocity and gravitational attraction maintains perfect equilibrium for each world. This equilibrium has persisted for billions of years and will continue for billions more. Gravity is the eternal law binding all worlds to their destinies. Moons circle their planets in ancient rhythms that transcend human understanding of time, following patterns that never change across eons. Each satellite moves in predestined orbits, influenced only by gravity and the mass of its planetary companion. The regularity of these motions provides comfort and certainty in the cosmos. Moons are eternal watchers, circling their worlds without pause or variation. Stars twinkle in the night sky as we gaze upward, though their light has traveled across the void of space for years to reach our eyes. Some stars we see today no longer exist, their light reaching us from a distant past. Looking at stars is seeing history written in light. Each star represents a distant sun, perhaps with planets of its own circling silently. Asteroids drift silently through the space between planets, rocky remnants of a time long past, continuing their solitary journeys through the cosmos. These ancient objects have orbited since the solar system's formation, witnessing events only rocks can comprehend. Their paths are determined by the same gravity-guiding planets. Asteroids are monuments to cosmic age and persistence. Comets occasionally appear in the night sky as ghosts returning from distant regions, briefly becoming visible before disappearing into the void once more. When visible, they inspire wonder and contemplation about the cosmos beyond. The regularity of their returns provides a cyclical certainty to the heavens. Comets remind us that cosmic wanderers follow predestined paths like all other celestial bodies. The universe continues its infinite expansion outward from ancient creation, spreading worlds and stars across an ever-widening void. Though our solar system is but one small group among billions of galaxies and trillions of stars, it remains our home and our anchor. Contemplating this vastness reveals both our insignificance and our profound connection to the cosmos. We are made of stardust, particles reassembled into conscious observers of creation. All things circle, orbit, and return, through the eternal motions of the cosmos, from tiny atoms to massive galaxies, everything following paths prescribed by fundamental laws. The solar system demonstrates these universal principles on a scale we can comprehend and observe. Order emerges from chaos, patterns from seeming randomness, harmony from countless gravitational interactions. The solar system is a microcosm of cosmic truth and eternal motion. Worlds remain bound to their orbits eternally by gravitational forces that never weaken or release their hold on celestial bodies. The planets circle the sun in patterns established billions of years ago, following paths from which they cannot deviate. Each world maintains its position in the cosmic dance through the immutable law of gravity. The orbits continue endlessly, eternal as the stars themselves, constant as the turning of ages. Planets revolve in their slow and patient circles, moving through space at steady velocities that change imperceptibly across human lifetimes. Each orbit remains unchanged across millions of years, as stable and reliable as the breath of breathing itself. The gentle turning of worlds creates the rhythm of the cosmos. In this eternal motion, all things find their place and purpose within the greater whole. The worlds continue their journey, all together, never separated, bound as one family by the sun's invisible embrace and gravitational affection. No planet escapes its destiny. No world abandons its path. All remain together in the cosmic symphony of motion. The family of worlds moves as one through the universe, inseparable and eternal. Their unity transcends individual motion, becoming a collective consciousness of orbital harmony. The solar system persists in its ordered state, perfectly balanced between chaos and regularity, maintaining equilibrium across billions of years without interruption. The delicate balance of forces creates stability that has permitted life to flourish on one small blue world. This harmony is neither guaranteed nor permanent, yet it endures nonetheless. The system demonstrates that order can emerge from complexity and persist through the ages. The planets orbit eternally around the sun, their celestial motion continuing without pause or variation, day following night following day in infinite succession. The predictable rhythms of orbital mechanics create a clockwork universe where every motion is predetermined by mathematical laws. This orderliness offers comfort and certainty in a cosmos that might otherwise seem random and chaotic. The planets are the metronome by which we measure cosmic time. All worlds follow their destined paths, neither straying nor hesitating, their courses fixed since the moment of their formation in the nebular disk. Billions of years have passed with these orbits unchanged, and billions more will pass with the same steadfast devotion to predetermined trajectories. The planets ask no questions about their fate. They simply continue their motion without complaint or doubt. In their silence, the planets teach acceptance of destiny. The worlds rest in their orbits, suspended in the void by forces beyond human comprehension, yet understandable through the language of mathematics and physics. Each planet floats in its appointed place, neither too close nor too far from the sun, held in perfect gravitational equilibrium. This balance represents the crystallization of chance and physics working in harmony. The resting worlds are monuments to cosmic order and ancient precision. Worlds exist in the darkness of space, illuminated only by the distant sun and by starlight reflected across incomprehensible distances. Each planet is a world unto itself, unique and alone, yet connected to all others through invisible gravitational threads. In their solitude, the worlds demonstrate profound interconnection. The darkness that separates them also binds them together in cosmic fellowship. The planets continue their silent dance through the eternal night of space, moving without sound or fanfare, their motion visible only through patient observation. The celestial waltz continues, whether observed or unobserved, indifferent to human awareness of its existence. The cosmic dance requires no audience, no applause, only the fundamental laws that govern all creation. In their indifference, the planets achieve perfect grace. And so, the solar system endures, the sun at its heart forever burning, the planets forever orbiting, the moons forever circling their worlds, and all the asteroids and comets forever following their paths through the darkness and the cold. The cosmic dance that began 4.6 billion years ago continues unbroken and will continue for billions of years more until the end of all things. In this eternal motion lies the truth of existence, the poetry of physics, and the promise of forever. The solar system is home, and in its rhythm we find our place in the cosmos.